Alright, welcome to today's class. In today's class, we'll be dealing on the dimensions of physical quantities. What are the dimensions of physical quantities? The dimension of physical quantity explains how physical quantities relate to fundamental quantities such as mass, length, and time. There are two kinds of physical quantities, and they are fundamental quantities and derived quantities. Now let's consider fundamental quantities. Fundamental quantities. Fundamental quantities are basic quantities that are independent of others and cannot be defined in terms of other quantities. The units of fundamental quantities are called fundamental units. Now let's take a look at the different kinds of fundamental quantities. The different types of fundamental quantities. Here we have fundamental quantities, we have the units, and we have the symbols. The first type of fundamental quantity we have here is length, and length is measured in meter, and the symbol for meter is m. And also we have mass. Mass is measured in kilogram, and the symbol for kilogram is kg. We also have time. Time is measured in seconds, and the symbol for second is S. We have electric current. Electric current is measured in ampere, and the symbol for ampere is A. We have here temperature. Temperature is measured in Kelvin, and the symbol for Kelvin is K. We have amount of substance. Amount of substance is measured in mole, and the symbol for mole is MOL. And finally, we have luminous intensity. And luminous intensity is measured in candela, and the symbol for candela is CD. So far, these are the types of fundamental quantities. Now let's consider derived quantities. What are derived quantities? Derived quantities are those quantities obtained by a simple combination of fundamental quantities. They are dependent on the fundamental quantities and units. Now take note of this. Fundamental quantities are independent. That's to say, they rely on themselves. But derived quantities are dependent on fundamental quantities. You have to combine two or more fundamental quantities for you to get a derived quantity. Let's take a look at the types of derived quantities. The first type of derived quantity here is area. Area. And the abbreviation for area is capital letter A. And the formula for area is length multiplied by breadth. So we have length times breadth. So area is equal to length times breadth. And length, as I earlier said, is measured in meter. length is measured in meter, multiplied by breadth itself is also measured in meter. So therefore, area is equal to meter multiplied by meter is meter squared. So we have meter squared. The second type of derived quantity here is volume. And volume, the abbreviation for volume is V. The formula for volume is length times breadth times height. So volume is equal to length times breadth times height. So volume is equal to length times breadth times height. So we have here length is measured in meter. So write meter multiplied by breadth is also measured in meter multiplied by height is also measured in meter. So therefore, volume is equal to meter multiplied by meter multiplied by meter gives you meter cube. So m raised to power 3. So the derived unit for volume is meter cube. The third example of derived unit is density. Which is rho. And the formula for density is mass all over volume. So we have mass all over volume. Now remember that mass is measured in kg. Mass is measured in kg, kilogram. So we have kg all over volume is measured in meter cube. So we have m raised to power 3. So therefore, density is equal to kg multiplied by m raised to power negative 3. So this is the derived unit for density. The fourth derived unit here is velocity. Velocity. And the abbreviation for velocity is V. Velocity is equal to displacement all over time. Displacement divided by time. Velocity is equal to displacement divided by time. And displacement is measured in meter. So displacement is measured in meter. So we have m all over time is measured in seconds. So we have m all over s. So therefore, velocity is equal to meter per second. meter per second. So this is the derived unit for velocity. All right, we have acceleration. Acceleration. And its abbreviation is A. The formula for acceleration is change of velocity all over time. So acceleration is equal to change of velocity and then all over time. So we have here, now remember that the derived unit for velocity is meter per second. So we have ms raised to power -1 all over time is measured in seconds, which is s. So therefore, acceleration is equal to meter per second squared. So this is the derived unit for acceleration, meter per second squared. Finally, we have force. Force is a derived unit and its abbreviation is F. The formula for force is mass multiplied by acceleration. So we have mass multiplied by acceleration. The derived unit for force is Newton. The derived unit for force is Newton. Newton can be written as capital letter N. Alright, if you're yet to subscribe to this channel, kindly subscribe now. And also, if you understood this lecture, kindly type understood in the comment section. See you in our next class.